Dr. Jens König, physicist. Ulrich Graf, electroengineering. Dr. Markus Willert, engineer. Thorsten Bauer, Doctor of Engineering.
Schwieberdingen near Stuttgart, a team of researchers at Bosch is setting out on new paths in the use of laser light. The secret of their success?
Curiosity and believability. A good researcher loves detail, determination, and focus.
Industrial microprocessing is to be revolutionized with the help of ultra-short pulse laser technology.
Imagine turning a light switch on and then back off 1 second later. The light travels in this 1 second from the Earth to the Moon, and the energy is distributed along the entire distance between the Earth and the Moon. If we now take our ultra-short pulse laser system, then all this energy is compressed to a very short distance of just 1 or 2 millimeters in length, and we develop tremendous intensities in these short time periods and in these short lengths.
This results in maximum precision in machining even the smallest components. Mass production is already being planned for diesel injection systems.
Here we're talking about this injector casing. The diesel nozzle is positioned and tightened. It has to seal tightly. The escape groove you see here around the high-pressure drill hole, where there are pressures as high as 3,000 bar, helps to keep the injector tight throughout its entire service life.
The ultra-short pulse laser engraves a circular channel around the high-pressure drill hole. Through this channel, fuel can be returned to the circuit.
The trick is that material has already been vaporized even before it notices that it's been heated. That was never the case before, and no technology was able to carry out such delicate machining. This has become possible only now with ultra-short pulse technology.
This makes injection systems even more reliable while boosting performance and reducing environmental impact. Exhaust gas sensors, too, have already become faster and more precise with this new technology.
There's a tiny element of ceramic inside this lambda sensor built into the engine. This ceramic element is the actual sensor. You can see a tiny hole here. The exhaust passes by this element, and the exhaust gas properties are measured in this hole. It is now possible, in order to achieve the most precise possible measurement, to use our laser to apply minuscule trimming cuts to calibrate the sensor according to the exhaust gas very precisely.
Before it is introduced into assembly line production, this new generation of lambda sensors is tested for several thousand hours. The Bosch plant in Bamberg, and the site of a world premiere. In 2007, the new process was employed successfully in mass production of lambda sensors.
A researcher has to be inquisitive, he has to want to get down to the bottom of things, and he certainly needs a degree of doggedness.
Those are properties the young engineer and the product developers applied when successfully spurring this new process on and using it in mass production.
Here we use the ultra-short pulse laser to trim the sensor elements exactly to the specified value.
Surface texturing without microfissures, impossible when using other laser technologies on this particular material.
The ablation of the sensor element was developed and implemented at this factory and realized in this unit.
A milestone not only for Bosch.
The great challenges of introducing a new technology to mass production are quality, costs, and delivery. Quality stands for a functioning product and process reliability. Cost stands for prices acceptable to the market, and delivery describes attaining goals, launch dates, and process reliability all in parallel.
Technology to improve living and the environment.
I think we can be quite proud, not only of ourselves, naturally, proud of all the many developers who are behind us.
But there's one thing that won't be revealed in any case.
Exactly how it works.